Ever walk into a room and just completely forget why you were there? Like, what was I doing? It happens to all of us, right? But imagine if that feeling, that kind of disorientation, that fuzziness in your memory, imagine if that was happening all the time. Or picturing yourself trying to navigate a new city. All the streets are unfamiliar, but you have absolutely zero sense of direction. Talk about frustrating, right? I mean, it would make learning and experiencing new things almost impossible.
Yeah, it really would. Our brains are so reliant on these intricate systems of memory and spatial awareness. And well, as it turns out, those systems might be more connected to our environment than we realize.
And that's what makes this deep dive so interesting. See, we're going beyond the usual suspects like, diet, exercise, sleep, all that good stuff. We're exploring how something completely invisible, magnetic fields, could actually be influencing our brains in some pretty surprising ways.
It's true. And we're diving deep into a recent research paper that looked at the effects of something called hypomagnetic fields. Basically, these are areas with a much weaker magnetic intensity than what we experience here on Earth, thanks to our planet's, magnetic field.
So it's almost like giving these mice a little taste of what it might be like to live in space where the magnetic fields are much weaker. Did they come back wanting freeze-dried ice cream?
Not quite, but the results were pretty remarkable. They found that after prolonged exposure to this weakened magnetic field, the mice started to show some signs of cognitive decline.
Okay, so walk us through this. How do you even begin to test a mouse's memory?
So there are a couple of really fascinating methods they use. One's called the open field test. It's pretty much what it sounds like. You put a mouse in a new environment, a brightly lit box, and you see how they react. Do they scurry around and explore every corner, or do they kind of stick to the edges, a bit hesitant and unsure?
So like the difference between someone who dives headfirst into exploring a new city versus someone who sticks to like the familiar tourist spots.
Exactly. And the mice who'd been in that hypomagnetic field, they were much more hesitant, less likely to explore, almost like their sense of space, their memory of how to navigate had been altered in some way.
So after their low magnetism vacation, these mice came back with worse spatial reasoning than a tourist with a bad map, basically. But their memory was also affected, right?
Right. And for that, they used the novel object recognition test, which is basically seeing how well a mouse remembers encountering a new object.
Okay, that one actually makes a lot of sense to me. I feel like I fail that test daily as a human, always misplacing my phone. But what happened with the mice who are exposed to the weaker magnetic field?
They were significantly worse at remembering those new objects. It kind of paints that picture of a fuzzy, less reliable memory we were talking about.
Wow, so we've got these hypomagnetic fields affecting their spatial reasoning and their object recognition. That's a pretty big deal, right? I mean, what do they think is causing this cognitive decline?
Well, this is where it gets even more interesting. So the researchers, they dug a little deeper to see what was happening inside the brains of these mice, specifically in a region called the hippocampus, which is super important for memory and spatial navigation. And they think they found a potential culprit at the cellular level, something called oxidative stress.
Oxidative stress. Okay, that sounds a little intimidating. Give us the layman's explanation here. How does that relate to our brains forgetting where we put keys?
Imagine your brain's memory center is, well, getting rusty. That's kind of what too much oxidative stress can do. Basically, it happens when there's an imbalance in our cells. Too many harmful molecules called, get ready for it, reactive oxygen species, or ROS, and not enough antioxidants to neutralize them.
ROS, antioxidants. It's like a microscopic battle happening in our brains all the time.
That's a great way to put it. And in this study, researchers saw that the mice exposed to the hypomagnetic field had increased levels of these ROS molecules in their hippocampi.
So the weak magnetic field somehow tipped the scales in favor of the bad guys, those ROS molecules, and that led to more rust in the memory and spatial awareness areas of their brains.
Fascinating. But how exactly does a magnetic field, or the lack of one, do that? Did it scramble their neural circuits or something?
It's not quite that simple, but you're on the right track. It's not just about the structure of the brain, but how those structures are functioning on a molecular level, and this is where it gets really interesting. Researchers discovered that the hypomagnetic field was actually affecting the expression of specific genes in the mice's brains.
Hold on. You're telling me that exposure to a different magnetic field messed with their genes. That's wild. It is wild, isn't it? And it's not just any genes. These were genes directly related to how those ROS molecules we talked about, how they're produced and how the body deals with them.
So it's like the hypomagnetic field was like tampering with the instruction manual for their cells, causing them to churn out more of those harmful ROS molecules and making it harder for their bodies to clean up the mess.
A great analogy.
Uh,
And that disrupted balance, more production of the bad stuff, less detoxification, could explain that increased oxidative stress and the cognitive decline that we see in the mice.
This is absolutely blowing my mind. We've gone from forgetting where we parked to a potential link between magnetic fields, our genes, and this delicate balance of molecules in our brains.
There's a lot to unpack, and we're just getting started.
We're seeing this domino effect here. Fascinating how these tiny magnetic changes could have these ripple effects, affecting something as complex as memory. But this wasn't just some abstract lab experiment, right? This research has some real-world implications, especially when we think about space travel and astronauts and things like that.
Absolutely. And that's actually one of the most compelling aspects of this whole thing. It's potential relevance to astronauts, especially those on those long-duration space missions. Think about it. They're venturing out beyond the protection of Earth's magnetic field, going into these environments with significantly weaker magnetic intensity, very similar to what those mice experienced in the study.
So are we saying that spending too long in space could actually make astronauts' brains rustier? That's a kind of a terrifying thought for anyone hoping to make it to Mars someday.
It's definitely something that researchers are paying very close attention to. We can't just directly extrapolate these findings from mice to humans, but this study is a bit of a, yellow flag, a sign to proceed with caution. Imagine sending astronauts on this years-long mission to Mars, only to find that their cognitive function, their memory, their spatial awareness starts to kind of deteriorate along the way.
Yeah, that's adding a whole other layer of complexity to space travel, right? It's not just about keeping astronauts physically healthy, but mentally sharp as well. So how do we tackle this? Are there things we can do to protect future space explorers from these potential, cognitive risks?
That's the million-dollar question. And researchers are exploring several different avenues. One possibility is that, maybe we can create artificial magnetic fields within spacecraft. Basically, you're building a mini version of Earth's protective bubble to kind of shield astronauts during these long journeys.
So, giving the spacecraft its own, magnetic force field, that sounds like something straight out of science fiction.
It does, doesn't it? But it's a serious area of research. Another approach is looking at countermeasures, things we could do here on Earth, things like, specific diets or medications that could potentially help combat that oxidative stress that seems to be made worse by these hypomagnetic conditions.
Right, because if we can figure out ways to boost our natural defenses against those ROS molecules, those rust agents in our brains, that could have huge implications, not just for space travel, but for brain health in general, for everyone here on Earth.
Absolutely.
Yeah.
And that's what's so exciting about this research. It's not just about understanding the brain in isolation, but how the brain interacts with its environment on this almost like invisible magnetic level.
It makes you wonder what other subtle environmental factors could be influencing our brains in ways that we haven't even begun to, grasp.
It's a humbling thought, isn't it?
Yeah.
We tend to think of our brains as these self-contained organs, but this research really highlights how connected they are to the world around us.
And speaking of interconnected, it occurs to me that, we live in a world that's just saturated with technology. And all that technology emits electromagnetic fields. Could this be another piece of the puzzle?
Now, that is a fascinating question, and it's one that researchers are actively investigating. You see, this particular study focused on the effects of extremely weak magnetic fields, like what you might find in space. But it does make you wonder about the cumulative impact of even these subtle magnetic fluctuations in our everyday lives.
It's like we're swimming in the sea of magnetic information, right? And our brains are just constantly tuning in, adjusting, responding to it all. It's kind of mind-blowing when you think about it. Who knows what kind of impact that's having on us, especially long-term.
It really goes to show how much we still don't know about the brain and how it interacts with everything around it. Yeah. But that's what makes science so exciting, right? Yeah. Every time we uncover something new, it opens up even more questions to explore.
And speaking of new discoveries, let's bring it back to that groundbreaking research we've been discussing today. You send over this particular study because it goes beyond just observing something. It actually starts to untangle the mechanisms at play, like that chain of events connecting those weak magnetic fields to these actual changes in the mice's brains.
That's exactly it. And finding that link to gene expression, that's potentially huge, because it suggests that being exposed to these different magnetic fields, it's not just a fleeting thing. It's not like a temporary glitch. It might actually be changing how our cells are functioning at a really basic level, like how they're managing those harmful molecules we talked about.
It's almost like the software of our cells is being rewritten by these invisible forces all around us, which is amazing, but also a little bit unsettling, if I'm being honest.
So where do we go from here? What are the big questions that scientists are hoping to answer next?
Well, I think one of the most pressing questions is whether or not these findings hold true for humans. Mice are incredibly useful in research, but obviously we're a lot more complex than mice.
We hope so, right? Yeah. Right. So researchers are going to be looking to do similar studies in humans, maybe with astronauts on the International Space Station or even here on Earth, using like special simulation chambers to recreate those conditions.
And let's say those studies do confirm a similar link, between magnetic fields and gene expression and cognition in humans. What then? What does that mean for us?
Well, like we were discussing earlier, it could completely change how we approach long-duration space travel. I mean, we might need to start really focusing on developing those magnetic shielding technologies or some sort of like tailored countermeasures to protect astronauts' brains.
Almost like giving astronauts specialized, I don't know, magnetic supplements. I don't know what you'd even call it, but you know what I mean.
Right. But then there are the implications for those of us who are staying put here on Earth. Because if these subtle magnetic changes can impact our brains, what does that mean for us in this increasingly tech-filled world we live in?
It's like you said before, it's humbling to realize how interconnected everything is.
Hmm.
How our brains are linked to the environment even in ways we can't see. Honestly, makes you think twice about those times when you're feeling spacey or forgetful. Maybe it's not just you. Maybe it's the magnetic fields all around us.
A symphony of magnetic fields that we're just starting to understand.
Well said. So listeners, next time you walk into a room and completely forget why, don't be too hard on yourselves. It just might be, a bit of magnetic interference. But in all seriousness, pay attention to this area of research because it's revealing some incredible insights about our brains, our environment, maybe even the future of space exploration. Thanks for joining us.